Hello friends, in this episode we will continue a conversation on how to achieve high availability and disaster recovery with YugabyteDB across multiple regions. In the previous episode we took a look at one of the patterns. To be more specific, we deployed two standalone YugabyteDB clusters across two regions in Azure. And one of those clusters served as a primary, meaning that the applications by default connected to that cluster and the cluster was serving read and write workloads. And then we used the asynchronous replication to move changes from the primary to the secondary cluster that was located in a different location. With that configuration, we managed to achieve disaster recovery, we managed to tolerate region-level outages, but our recovery point objective was not zero because we used the asynchronous replication. And in today's episode, I'd like to review another pattern that is unique to Yugabyte and other distributed SQL databases. It's called global database or stretched database. What we will do, we will deploy a database instance across multiple regions, and then we will let the Raft consensus protocol to replicate changes synchronously across those locations. And by doing that, we will be able to achieve recovery point objective of 0, no any data loss, and the recovery time objective measured in seconds. And we will be able to tolerate region level outages. And now, I know what some of you might be thinking. Hey Dennis, come on, you're telling us to deploy stretch clusters across several regions and then use synchronous replication? Come on, what's going to happen with the latency, especially with the write latency? And it's all about how you deploy your cluster. In this video, you will learn that yes, it's possible to deploy a single cluster across multiple regions and yet have very nice and good write latency. So let's not waste a minute and do a deep dive. Alright friends, let's get started. I will be using YugabyteDB Managed today, which is a fully managed offering for YugabyteDB in a cloud. I need to select a dedicated deployment option and I will pick Azure. Why? Because I used this cloud environment in our previous episode with 2 data centers. Clicking next, and on the next screen we need to select between single region deployment or multi-region deployment, and guess what? We go forward with the multi-region deployment option. Next, we need to select the data distribution mode, and the mode that I needed is called replicate across region. This one you use when you deploy a global database instance or stretched database cluster. According to the configuration, I want to tolerate at least one region outage, and this option is already selected. Scrolling down, where we need to pick the regions for our application. Let's assume that our primary user base in the United States East Coast, and that's why I'm selecting the United States East 1 region. Then the second region that I want to have is also in the United States East, but that's the second one. And just in case if there is some meltdown in the East, I want to have a copy of the data in the United States West. Let's select this option. Yeah, nice, cool. And the next configuration that is related to optimization, because we also want to minimize the latency in this type of deployment, is a preferred region. With the preferred region, the primary copy of the data will be stored on the nodes that are located in one of the regions. And by doing that, you will be able to minimize the cross-region traffic because the applications by default will connect to your preferred region and they will be reading and writing data there. And then from the preferred region, the data will be replicated synchronously to the other locations. As long as my primary user base is the United States East, I will select the United States East one as the preferred region. And you can have as many nodes as you like in this location. It's up to you. Just for the sake of simplicity, I'm selecting one node per region. Okay? And why I selected United States East 2 as another region? Because the distance between United States East and East 2 is quite short, and that will allow me to minimize the write latency when the Raft consensus protocol will be executing our transactions and replicating them across several locations. Finally, let's click next, let's move forward, so then you can configure your network and security later. Finally, don't forget to download credentials and click the Create Cluster button. And our cluster is ready, my friend. Let's quickly take a look. I have 3 nodes as it was planned in different regions: United States East 2, West 3, and East 1. If you go to the settings tab and scroll here, you will find that East 1 is a preferred region, as expected. Also, I will be able to connect to all of those nodes to all of those locations using private service endpoint. I configured those endpoints after the cluster was started. What you can do, you can also configure those private service endpoints if your application instances are going to be deployed in Azure, and that's my case, or you can go forward with the IP allowed list, giving access to specific machines. Now, let's quickly talk about our application and get connected to this database cluster. As I said, the application is going to be running in Microsoft Azure on the following virtual machine. It's already waiting for me to SSH to. Let me SSH there. I'm going to use my certificate. Excellent, I'm in. Let's go to my application. It's called Market Orders application. The application connects to a third-party service that generates market data. We will be consuming different trades, processing them locally, and then storing in our multi-region database cluster. The application is written in Java, and let me show you the connectivity settings to our database. We will be using the standard JDBC driver for Postgres. And then this is our database connection endpoint. This is our driver. And by default, the driver will connect to our nodes in the United States East, which is a preferred region that stores the primary copy of our data. But then what we want to do, in case of any region level outage, we want the driver to automatically reconnect to either United States East 2, and the driver is capable of doing this by default, or to the United States West 3 region. Okay, and then you need to provide your username, your password, and SSL also needs to be enabled. Okay, cool. Let's move forward and start our application. We are using this command. Connected to the database, we created the schema, and now we successfully connected to that third-party service that generates market data, and we are storing this data into our database. Now, take a look at the latency. The read latency is around 1 or 2 milliseconds. Why? Because the application instance is deployed in the United States East, and this is the location for our preferred region. This is where the primary copy of the data lives. That's why the latency is low. If you will have application instances in other regions, then those application instances also can connect to the primary region, or they can read data using the follower reads from the database nodes in other locations. Let's talk about the write latency because it's very interesting. Remember that we have database nodes spanning United States East and West, and those of you who know the latency between East and West might be surprised. The latency is usually around 65 milliseconds, but why the write latency is so low? Remember, I was telling you that when you deploy a global database cluster and you want to use the Raft consensus protocol, then it really matters the region that you select. And we selected 2 regions in the United States East, and those regions are not that far from each other. And when you are executing those transactions, the Raft consensus protocol needs to come to an agreement with 2 nodes, with 2 regions. It needs to get the acknowledgement from the 2 locations. And as long as the East and East 2 are not far away from each other, then a transaction will be completed much faster. We don't need to wait for an acknowledgement from the United States West 3. So this is how you can achieve the low write latency for a multi-region setup stretching the entire United States and be tolerant to region-level outages without any data losses. Now let's talk about the fun part, about region-level outages and how this application can tolerate them. What I will be using for my experiments, I will emulate an outage in the United States East region in our preferred location for the data. How do I do this? If you know YugabyteDB managed, you can set up API keys. And by using those API keys, you can stop or kill the nodes from a selected location. And as long as in my current configuration, I have just 1 node in every region, if, let's say, I stop this node in the preferred location, then I will emulate a region-level outage in the United States East. Let's do that, right? Okay, so we want to monitor the logs of our application because I expect no any data loss, and recovery time objective is going to be in seconds. Let me split the screen. And this is the request that I'm going to execute. I will execute this HTTP post request, connect to the YugabyteDB managed. I will be using my key, and I will ask to stop this node that is deployed in the preferred region. So this is the command. Let's do this. And it will take, some time for YugabyteDB managed to stop this node, but we will be keeping an eye on our application logs. Also, if we go to the YugabyteDB managed, we can see here that this operation has been queued. Now the node is being stopped. This is the status. Let's jump back to our application. And here now, let's take a look at the latency. The latency is much higher, which means that eventually some of the connections that were open to the node in the preferred region failed, and the driver automatically reconnected. Yeah, I see this exception here. This was the exception that I was looking for, because I was using the driver and I was using a connection pool. Some of the connections obviously were open to the nodes in the preferred region. I stopped this node, I've got this exception, and the driver just reconnected to the other nodes in different locations. So how it happens from the source code standpoint, that's the logic that inserts those traits into the database. And if any connection fails, I'm restarting this failed transaction. Now the read latency is obviously higher and the write latency is higher. The read latency is high because my application in the east needs to send a read request to the nodes in the east 2 or west, and the write latency is also higher because the traffic needs to travel east and west several times. But this is the application that is running during a major incident, right? And you usually have two options. Either your application is down or you give up some latency, because this is a global incident and we managed to tolerate this incident, no any data loss, and it took us just a few seconds to restart failed transactions, so the application keeps running normally. Cool. Also, if we go to YugabyteDB managed UI, we will see that this node is down. What I want to do next is to restore this database node, because there is always the light in the end of the tunnel. And let's assume that United States East region was restored. And I emulate this process by asking YugabyteDB managed to start this node back. Okay, it says that another operation is in progress. Let me execute this operation one more time. Okay, this time it succeeded. And I'll go to their clusters. I will be waiting while this node is back, and then we'll take a look at what happens to the latency. Excellent, the node is back, it's joined the cluster and it's running in the United States East as it used to be before the incident. Now let's jump back to our application and check the latency. The latency is much better right now after that node has joined us back, but for some reason the read latency is not 1 or 2 milliseconds as it used to be, and the write latency is higher. It used to be 17 or 15 milliseconds. Why so that? Because our driver is still connected to the United States East 2 region. To fix this, we need to restart our application. And before we restart this application, I want us to take a look at the connectivity settings from the app to the database one more time. If you remember, by default the driver was connected to the United States East because that was the first host name that is listed in this configuration. However, when the node from that region went down, the driver automatically reconnected to the United States East 2. However, when we restored our United States East region, the driver did not reconnect back to it automatically because the driver doesn't support this. However, the good news for you who are using YugabyteDB, you can use YugabyteDB Smart Driver, which is an extended version of the standard JDBC driver of Postgres, and the Smart Driver of YugabyteDB can learn IP addresses of the nodes on the fly, and it will be able to reconnect to the nodes in the preferred region if necessary once the preferred region is back. So when you go in production with YugabyteDB, use the Smart Driver, and I use the standard driver today just for the sake of experiment. Now, let's restart our application, and I'm interested in the latency. And wonderful, now the latency is as low as it used to be before the incident. The read latency is around 2 milliseconds and the write latency is also around like 13-15 milliseconds. So congratulations, job done. How do you like this, my friend? Isn't it cool? Within a few minutes we managed to deploy a multi-region cluster, stretching the entire United States, and we tolerated a region-level outage without any data loss, and the recovery time objective was just within a few seconds. Plus, the read and write latency was extremely low for this type of file configuration. Remember, we were using the rough consensus protocol and the synchronous replication. So what's coming next? In the description to this video, you will find a link to an upcoming livestream where Frank and I will do a deeper dive into the different multi-region deployment options with the focus of high availability and disaster recovery. See you there. Come with your questions. Bye bye now.